Hello. Today we're going to go over the introduction for programming using C++. So let's talk about the basic concept of a programming code. What is code development? So when you talk about code development, you have to think about the source code and the executable. The source code is what we will write. And at this point, really depends on what language you use. For this class, we're going to learn C++, which is based on C. We're going to learn Python, which is a very common language now because of the flexibility and how scalable it is for different applications. These two are free, and we're going to learn a third one that is not free, but you have access to the college, which is MATLAB. And this one is very important for science and engineering because you do pay for the license, but MATLAB supplies or provides a bunch of headers and libraries for you to use, such as multisim, such as AI being artificial intelligence, such as neural networks, machine learning, controls in Simulink, etc. So when we talk about the source code, this is what you write. The source code is divided in what is called the algorithm. The algorithm is a combination of plain English with programming language, or the code. The code is basically the language that you use for the script. So if it's C++, that's a type of language. If it's Python, that's its own language. And that is, of course, for MATLAB, it's its own language. But MATLAB and Python are built on top of a C++ GUI or graphical interface or application. Now, once you get your code on a developer, such as Visual Studio or Dev C++, we'll go over some tools that help you compile the code. Because the thing that you have to remember is that for source code, you can use, first of all, your OS, your operative system. So if you have Windows, then Visual Studio or Dev++ is a great option. We'll talk about that in a minute. If you use Linux or Mac, then basically you have the capability of any text editor being able to run your source code. So in your Node++ or your Notepad, whatever you use, you can create a new file, and just by saving it as .cpp, you can have a C++ code. Versus in Windows is not so easy. You actually have to install a developer, or you can go and run a developer on the cloud. So we'll talk about that in a few minutes. So what is code compilations? C++ and Fortran and those type of languages, Java, are compiled, versus JavaScript and Python are interpreted. So from your source code to the executable, there are a few steps that that the compiler takes or does for you. So that is the process that the source code gets translated into machine code, where you can run your code. Because, for instance, in your code, when you say x equals 3, yeah, and y equals 5, okay? When you say z equals x plus y, So all of this behind or underneath memory and the computer has to understand that, okay, a 3 is allocated on something called x. This is going to be a variable that, let's say 3.1, for instance, and 5.2. Right? So this is going to be a floating type of variable. We'll talk about that in a few minutes. And this is a floating type variable. And this has to be stored in dynamic memory. Okay? So this is just the introduction. We'll talk about this later, as I said. But if this is, for instance, pi, then pi will have to be constant throughout the whole code. The whole program will have the same value of pi. So this could be a global variable, for example, versus x and y could change throughout the code. Okay, so the global variables versus dynamic libraries and the headers where the computer knows what plus is, where, because remember, you write 3.1 or 5.2, but the code is saving this on memory as binary numbers, right? Where 3 will be something like this. Well, no, this is 2, 1, 2, 3, something like this, right? 1, 1. This is 3. And 5 will be something like 4. So if we have 4 spaces, we have 1, 0, 1. Right? So, or let me do that again. 0, 4. So this is 5, right? Where this is the sign plus. Minus is, if it's minus, will be 1. And this is binary. So, of course, you probably don't understand what I'm saying right now. This is, in binary, 101 is 5. 101 is 5. And 011 is 3. So we'll learn all those things, how to know which number is what in binary. But my point now is that the computer has to know that when you add those two numbers, binary numbers, you're gonna have something else. The way the computer knows that is by the headers or the libraries that are installed beforehand by the code. So that's the preprocessor part, the macros, and all those libraries that are installed when you have C++ on your computer, which, by the way, C++ is installed with the operative system versus Python and MATLAB, you have to install them extra. So C++ is very close to the language used for your computer because the OS on Windows, for instance, is built on top of C and C++. Computer viruses are done on C++, and many other important applications such as websites and things like that are made on C++. All right, so how to compile or write the code. So this is the first thing. If, by the way, this is what I recommend. If you don't want to install something locally, you can go and do it for free on the cloud on something called replit. So let's look at that. replit.com. So this is the app where you just have to create an account with your Google or Yahoo account, and you choose the language that you want to program with, and you can just create a new code. Example 1 using C++. Okay, and it will give you the terminal window or the console, and it will give you examples. So for instance, if you run this, it will compile it for you. This is the compiler. The main C++, save it as main executable, and then it runs and it says hello world. This is the very basic, very first program that anybody learns how to do. This is hello world. And to do that, in C++, you include the header, which is input output stream. So by now you're accessing all the built-in libraries that will let you get things published or printed on console, or you can ask for things inputted by the user. So we will learn how to get things that users have to type down. Okay. So any code that is written in C++ has a section that is the main section. Okay. The main section is what contains the whole body of the code, and outside the main section are the functions. We'll learn how to write functions. So the functions are created outside and are called from inside the main block. Okay, so this two / are comments. So this is important because this is how you tell other users when you work on a team. You tell that this is version, I don't know, 0.0, then date for first release, I don't know, it's May 2021 or June 2021. It's already June 2021. And so on and so forth. Now, if you want a block of comments, you just have to do this. And everything that you write here will be a comment. This is the other option. And in this case, you can say, this code has 1 output and 0 inputs. Right? So you basically comment the code for other people when they see it, know what's happening, because your code will get thousands of lines long, will have plenty of functions. Sometimes we'll have different files that are connected through libraries and through functions, or classes. So you want to be pretty organized with comments to explain what's going on. Okay, so as we said, this is the first thing. This is called a header. So this is a header. And this is used because we're going to print something through cout standard. So cout is console out, and that's what you're seeing here. So one thing that I want you to know is that every time you finish a line, you have to add the colon or the semicolon. This \n is jump line, so that, for instance, if you're going to say hello world, I am machine, right? So you run it. Look, so it's a jump line and it's saying I am machine. Versus if you do this, you have no jump line. So now this is a very important thing, not because of the printing as much, really at this point is not adding or subtracting anything to the code, but when we read and write files, that is a very important aspect because files have that /n built in at the end of the line. Okay, so if you want to create an account, which I recommend, is free, you can use the cloud for developing your code. If not, you can install a developer locally on your machine. They're not necessarily easy or no, they're easy to install, but not necessarily light. They could have some, they can occupy some room on your drive. So I try not to install those unless I really need to. And today I really need to. So let's go ahead and install the developer for our C++ projects. So again, if you want to use the cloud, the free version won't let you have many files created. So you probably have to, if you probably will have to say, okay, well, if this is my homework, I'm gonna copy and I'm gonna create a text file. Let's say if I go to text file here, new text file, and I'm gonna say, I don't know, homework 1, my name and date, whatever you want to name your file, and then you save it. Okay, and then you know that you can copy this on your C++ file. This is an easy way to do it. Okay, the other thing is that we can install developer, and for that we have to go to dev download. And that is the dev C++ download. Right. And it's going to be this one. You hit download. It's an executable. And I already have it installed, the 5.11 version. But the only thing that you need to do is click OK. Just save on the x86 location that dev C++ found for you. Just hit yes, OK, agree, and you will be able to install your developer locally. The other option that you have, which honestly I don't recommend for this particular class because we're not going to have any extensive projects really, because we're going to move to Python and MATLAB as well, so I don't recommend it. But another common option is Visual Studio, the community version, which is free. So you can install your Visual Studio developer by going to the Microsoft website and looking for community version. If at some point you become a developer, you can actually, or you should actually buy the paid version if you're going to be developing your code and selling your projects, like outsourcing or consulting. But just for learning and using C++ for your personal projects, Arduino and etc., you don't need to pay for Visual Studio. You just need the free community version. But I'm not going to install it even because I don't want all the excessive files, and it does require a lot of space on disk. So I'm going to refrain from installing it, but you can install it if you want. And as I was mentioning before, once you write your code, your source code on C++ in this particular case, when you hit save and compile or run, there are a couple steps that the computer is doing behind scenes. So, for instance, it's doing the pre-processing, which is the step where the computer specifies how a certain input should be mapped to a replacement output. So remember, for our floating case of x equal being 3.1 and y being 5.2 or something like that. In the preprocessor step, the code, the compiler looks at 3.2 in decimal, it will turn it into a binary number. The 5.2 and the 3.1 numbers will be decimal, binary, sorry. And those binary numbers then are summed. There's a summation, x plus y, that is also taken care in the pre-processing part. Also, the headers are loaded on this step, and the preprocessor is responsible for expanding macros and header files. So a macro is, say, a global variable. For instance, pi is a number that is going to be constant throughout your code. So by saying #define, you're creating a macro. And this part is processed by the preprocessor to be able to understand the rest of your code.
What is a compiler? The compiler translates the source code into object code, or sometimes called machine code. When we have the source code, or the code that we write in our language, C, C++, Fortran, etc., we go to the preprocessor. And from the preprocessor, the compiler executes commands to convert the code into machine code. The compiler in Windows comes built in for applications such as Dev++, which is what we're going to use for this class, or for Visual Studio. The compilers are already built in. But for Linux and Mac, you would have to get a compiler which is sometimes called a makefile. And the makefile is basically a file that would execute commands to compile your code and be able to run for your hardware. Then the linker produces the executable code. So your source code, in our case, is going to be a code.cpp, C++. After the compiler is going to generate sometimes called out, or some letter a.exe, and this executable is going to be your source code, and compiled, linked, and ready to execute. Then you can execute this code to run it. So remember that every time you make a change in your code, you have to go through the process. You pre-process it, compile it, so that it gets linked to the libraries, and then you run it. If there's a bug or an error and you have to change anything at all, you go to your source code, you change it, and then you recompile it. Most applications, really, you compile your code, and when you compile it, the compiler does everything else that we're seeing here, which is the pre-processing, compiling, and linker. But in the application, there's going to be a button that says compile, but really is doing all of this behind the application.
So why do we even care about computer programming? Well, because computer programming helps us execute tasks that are repeated multiple times. So think about making a part in a mill or a lathe, and has the same diameter, has the same radius, has the same dimensions. So the distances are going to be the same distances every time. So if you had a code for doing this part, you first minimize the errors, and B, optimize your process. So that's one reason why you want computer codes, because the tasks that are repeatable are performed efficiently and standardized. Also, we want codes to complete calculations faster, so you can complete all your computations in milliseconds instead of minutes. We want code to organize our data or to process our data. And also we want code to visualize information. So in engineering and science, mostly you're going to have a theory or a field that you're studying, which is trying to represent your physical world. In manufacturing, you have some process that is manual, but you want to automize, or you want to control sometimes. So make automatic, but controlling the process can be pretty tough. Therefore, control in this case, computer programming is linked with controls theory. This is a huge field of research, and a lot of industry depends on this field. And another thing is that you want your analog to digital components to work. So for instance, when you read your temperature is 70 Fahrenheit or 75 Fahrenheit, well, how you make a sensor that it can read this. This sensor needs a code, or sometimes called a transfer function, that a change in resistivity of a metal or a change in voltage or current from a wire will tell you what is the temperature for the plate or the temperature of the water that you're sensing. Okay, so let's go through some basic concepts in programming. First of all, we're going to focus on object-oriented programming, or basic concepts in programming. So first of all, we're going to focus on object-oriented languages, or object-oriented programming. This is sometimes called OOP, from object-oriented programming. And object-oriented programming, the key is to remember that you will be operating with objects. So a number, an array, a vector, all those things are objects. So another concept for programming, which is the functional programming, is HTML or F, Sharp, or other types of programming where you have a function and you basically transform your operations. But in basically what I want to say is that in OOP, or object-oriented programming, you have an object, say a car, that has some attributes such as color, size, shape, weight, etc. And there are some methods attributed to the car. So the methods are that it can move, that it can get gas, that it can brake, that it can go fast, that it can reduce its velocity, etc. So the key of OPP or object-oriented programming is to know that the objects that you deal with have attributes and perform methods. That's the whole concept. So right now it's very abstract, but in a few sessions we'll see that this is pretty powerful, because if your object is a bank account, then the attributes are your checking and your savings account. Your methods are that you can withdraw, that you can get interests, etc. So more about object-oriented programming. Everything in the code is an object. Okay, so this is a key concept. An object can store a value, perform actions, call methods, and return values. An object is defined using templates called classes. A class defines what a program can do, and programmers can create instances of a class. Programmers define tasks or algorithms to operate with objects. So as we mentioned before, objects are arrays, numbers, data, strings, names from a database, and then you can perform functions and operations with the data. Then the code, the source code, that's what you want to do with your data, perform some type of tasks or instructions. You compile your code if you're using C++, or you interpret it if you're using JavaScript, or if you're using Python. You're going to perform operation to convert your source code into machine code. Okay, so this part is right here, the compiling part. This part is the machine language conversion, where your code is translated into a binary set of instructions, and then your hardware is going to execute your code based on all the transistors and logical gates that are built in. A key concept in computers, which is a pretty basic low-level concept, is machine language. And in these languages allow programmers to write code to access directly to the hardware. Okay, so back in the day, in the 60s, even way before I was born, they didn't have screens or a way to see on a nice display what they were typing or coding or anything. It was pretty basic. So what they used to do was have a basic keyboard and connected to a printer, and the printer would basically print what you were executing. That's why you will see that one of the basic functions in every computer code is print. Okay, so print is a function that is built in for every code because, as I mentioned before, when they first started developing computer programming, they didn't have a nice display, an LCD screen. All they had was the keyboard and a printer, a very large printer. So what the way that they had to debug the code or to test the routines were by typing print in whatever they want to see, a variable, a string, whatever. So print is one of the key ways for us to test our codes currently. Well, right now you have debuggers and you have all sorts of tools that you can buy or download to analyze your code. But the very first code that was created was based on printing values to see if the code was working. Printing, like literally using the printer. So instructions are programmed in patterns of bits through the processor for actions to take place. So when we create a computer program or a code or a source code, we're actually using a language to talk to the hardware to execute instructions for us. Okay, C++ is a very low language, very a fundamental language, meaning that, for instance, Windows is created using C and C++. Therefore, you can create a lot of applications to run with your Windows platform already. Or like a virus, you can create a virus for a Windows PC. So this is a typo. These types of programming languages are also called native languages. So languages that can translate your source code into binary code or hex code or some type of machine code are sometimes called native languages. Assembly languages are another concept that uses code to modify processor registers. So this is a very low-level language as well, where you can actually use code to access your hardware and operate and make sure that you can get operations from your hardware. So if you notice when you install software on your computer, or if you go to your folder, there's going to be an x86 extension, and this is because Intel and all the computer makers, the manufacturers decided to create or to agree on a common platform, so that the processors and the RAM and the microchips can communicate using common language. So assembly is underneath all that. So assembly, it's called a low-level programming language because it has a very strong correspondence between the instructions and the machine architecture. So for instance, an Intel or i5 or i7 has a different architecture than an AMD processor. That's why there has to be a code that when you run your stuff on your computer can run your instructions regardless of what processor you're using. Before, it was you were pretty much limited by what processor you were using. Your software had to be designed for it. But now, really, you buy a computer and you don't care what processor. Well, I do care, but most people don't care about the processor that you buy, because now there are all these other instructions underneath that will make sure that your software is compatible with your hardware. Compiled languages. So as we said before, C, C++, Fortran are compiled languages. A compiler takes instructions written in a language, or source code or script, and links the commands with libraries and headers to generate native code for the hardware to execute. Compiled instructions run much faster than interpreted code. What that means is that C or C++ is much faster than Python. Okay, because we're also going to talk about Python later in the course. Each compilation creates an executable. So as we said before, if you have to change if you have to make a change in your code, you have to recompile it and re-execute it. It's not dynamic and versatile in the way that you can pretty much make changes while it's already running. Different platforms need different compilation code. So if you're using Linux or Mac or Windows, you probably have to make sure that your compiler will be working with the platform that you're using. And even if you're using C++ 17 versus C++ 11, you're going to have errors that you wouldn't have with a newer version. Interpreted language. The interpreted, remember Python is an interpreted language. JavaScript is an interpreted language. The interpreter is a component that reads each line of code to interpret and generate native instructions. This process is much slower since the interpreter has to convert each line of code into a native code. For instance, Python is designed on top of C++. So your Python code has to be interpreted using C++ commands. So imagine that extra layer of code. Python and JavaScript are interpreted codes, as we said before. Each change to the program needs an interpretation and execution. So the same thing, every single time that you make a change to the program, you have to re-execute it to make sure that it's running the latest version.